So I just want to make a couple sort of concluding remarks, just to tell you some stuff about Python. I want to show you like one more Python feature that I've been kind of holding back on. And then we'll let you go back coding or go have some more free food. So the first thing I'm going to do, I just have to establish as a point of order. All right, so what does readable code mean? Just think about that. It's like, well, I would say it's code that if someone who didn't write it, they kind of look down at the printout and they think for like they can kind of see what it does. And I would be willing to posit, we agree, like readable code, that's a good thing. Right? We like code that you can read. All right, so I'm just going to table that. I'm going to put that on the side for use later in today's discussion. All right, so I want to show you this feature. This is a feature I kind of thought about showing, but there was just so much going on. This was just one feature too many for our discussion. But this is something that you're now ready to use. So we've done a lot of stuff with lists. So I'm gonna set up a list here. I'll have like, AAA, BB, and CCC, let's say. All right. So there's a list of strings. And suppose I wanted to have a list of their lengths. We've seen how I could have said, well, result is equal to the empty list. Then I could have, I looped through list A and added stuff to the result list. And you know what? That is a fine technique. But Python has a feature called a list comprehension that is a syntax for just making lists with a very kind of compact syntax and just making them in one step. And so I want to show you the list comprehension syntax. And so my first problem will be like, what if I want to make a list length 3 of the lengths of those strings? So it kind of parallels the list of strings. So the list comprehension syntax is like, I'm not sure what adjective describes it. But anyway, here's the way I do it. So the list comprehension syntax, what you start off is you write a set of square brackets. And then you're going to put code inside of there to represent the list that you want to compute. This is the way I do it. So I type the square brackets, and I go into the middle here. And then the list comprehension syntax, it reuses as much of the existing syntax as possible. So what's the existing syntax we know? It's the for loop. So I say, I say for s in A, right, for each string inside of there. And then for the list comprehension syntax, then on the left-hand side, you put the value that it would like to use. What function would you like it to run on each s in this case? So I'm going to say, what's len of s for s in A? And if I just hit return there, that just in one step just makes the new list. So if you wanted to have, you have a kind of a list of one sort. This is in Lisp, you would call this a map car. If you have a list of one sort and you want to kind of transform it to a list of another sort, then this is exactly what the list comprehension does. Let me show you another example. I'll show you another feature it has. So let's say I have a list with 1, 2, 3, 4 here. Oops. All right. And now I'll write a comprehension. I'll say for num in A, and let's say I wanted to do squares. So I could say, num times num for num in A. So I could just make the squares that way. You can also add an if statement on this if you want to kind of do what you would maybe call a filter operation. So I could say, well, I want num times num for num in A if, I don't know, num is greater than 2. And so now this kind of runs over the list, and you're sort of slicing off some elements and then computing this thing for it. So I'll show you just a last example. Let's see, what directory am I in here? Oh, good. All right, I'm in the copy special directory. So as the last example, we had that, I'll import OS. So we had that os.listdir thing, right? I'll say listdir of dot. All right, so there's that list. So I'm just going to, can we just write a comprehension to just make the list of special files all in one step? And I'm kind of pushing the envelope a little bit here. So I'm going to say import re. So here, I'll do the square braces. So I want to say for f, I'll say, this is the file name. For f in os.listdir of dot. OK, so now I want to say, I just want f. So it's f for f in os. And then I want to add an if statement here, right? I want to say if re.search, and what was it? Like r quote underbar underbar backslash w plus. This isn't cryptic at all. I think that, so let's just try it. Yeah, check it out. So there's a bunch of things kind of getting compacted in there, right? I mean, there's the search, the regular expression, or whatever. OK, so for small problems, the list comprehension is very attractive. And it feels like you had this idea in your mind. It's always nice if you have an idea in your mind, and then the amount of code to kind of express that idea is small. You didn't feel like you needed to add all this extra barricades and stuff to kind of like get your idea out there. And list comprehensions definitely have that feeling. Although I think the syntax is a little foreign at first. I mean, but you get a little bit comfortable typing out. And the mnemonic, for what it's worth, is that it reuses the for loop and the if statement as they exist and sort of just puts them in the square bracket. That's kind of the way to remember it. Except for that thing about the expression on the left. That you just have to commit some brain cells to remember that one. All right, so list comprehension is very attractive. And according to the Google style guide, we would be very happy to use these so long as they were 1 or 2 lines long. And now I have to give you this warning, this Surgeon General required warning whenever you are showing someone the list comprehension. And the warning goes as follows. There is this form of madness that can take over a programmer. And the madness is of this form. You had a program, and it was like 100 lines long. And your office mate used a bunch of macros and weird features that no normal person ever uses. And they got it down to like 80 lines. And you saw what they did, and you're like, oh, that's nothing. And you like use more and more esoteric features or whatever kind of stuff. And you sort of get it down to like 3 lines. It's just this unbelievable thing. And it's so satisfying. I mean, it is actually very satisfying to feel like your cleverness is being totally working, and wow, you have this thing like completely condensed. So the problem is that it's a path. It like pulls you on that path. But in reality, what you have created is completely unreadable. Right? It is not that someone could look at that and say, what does that do? So the list comprehension, I mean, it's like a dog. It's like that scenario I described is a risk factor. So the list comprehension is great for like a couple lines long, but what you can do is you can nest them. You can have an inner list comprehension that does something, and then that's nested inside of another one, inside of another one. You can sort of take your entire program and just have it be like this nested list comprehension. But I would definitely recommend that you not do that. Or as I would say, it's kind of like with great power comes great responsibility. So this is a very nice feature if you feel like it's still readable and sensible. But just like, don't go out of control. Yeah, question?
Is it faster?
Is it faster? I don't think it's going to be really faster. Not especially. I mean, the trick is you figure the for loop, like the for whatever append. I mean, that is a highly optimized case. That's a super, super common thing to do in Python. So I think these are both well optimized. I don't think it's slower either. I mean, I guess it maybe has some slight advantages, but I don't think it would be significantly faster. All right. So I just want to show you that. It was kind of for fun. The other thing I'll mention is that, well, I just want to talk about, Python and you. What does this mean a little bit? So Python is actually a pretty popular language, and its popularity seems to have gone up a lot in recent years. And I think certainly in this class, you've gotten kind of a feel of, in a sense, I've tried to give you assignments or projects where Python looks pretty good. Right? So Python has the list is nice, the string is nice, the dictionary. So anything where you're kind of pulling in data and using those things where Python is good, those are going to work pretty well. I think that's one area of strength. Also, syntactically, it's pretty short. I think that makes you're not typing a lot of extra stuff, and so that makes it attractive for small problems. And then finally, like a lot of modern languages, I think Python, you benefit from the URL lib and regular, all those kind of modules that are sort of out there that you can build on top of. And so. Yeah, out in the real world, if you look at scientists or universities or companies or whatever, yeah, a lot of people find Python to be like a really nice fit for problems they actually have, and so it gets used a lot. And certainly within Google, it gets used for like all sorts of stuff. And I think I will speculate that probably the amount of languages like Python or JavaScript or Java or whatever is just gradually on the way up in Google as they save programmer time, and they use a little more memory, a little CPU, but ultimately programmer time is something that is extremely expensive and rare, and so something that allows us to save programmer time is a little bit attractive. So what I would say, so I have to give you one warning. So Python is in fact a large language. If you really looked at all the features that this language has, there's a lot to it, and we have not covered all those things. That's bad news. Good news is you have absolutely seen the core of the language. Like the very common, straight-ahead, normal features that you would want to use to solve a lot of problems, you have seen them. And in fact, you've written projects that use a lot of them. So I would say from here on out, you should feel very comfortable. If you wanted to read a Python book or go to some Python talk at Google or whatever, like, yeah, you have definitely seen the basic core stuff. And so I think you're well set up to kind of go from here and sort of learn more Python if you want. My last piece of advice about that is that I found the way you learn this stuff is by writing code. right? I mean, you can watch talks, but really it's the writing code. And certainly in this class, hopefully, you're writing solving some of these problems, you learn something. And so for myself, or say, for example, within Google, my Python stuff got stronger when I started forcing myself to solve things in Python. And so the first offender there was really bash. So things that I might have solved as a shell script. And especially, I think bash works well if you're just calling programs and just sort of dumping their output to text files. Like that's fine. Or like I can write a correct bash script so long as it has at most one if statement in it. Like then I can sort of get that right. But if you find yourself in bash, like reading the data in and sorting it and uniquing it and cutting it into tabs and all that, sort of doing data processing in bash, then I think Python maybe looks pretty good. That if what you could do is instead call the program from Python, but pull the data into Python for processing. So you can use regular expressions and hash tables and all that kind of stuff. So I think that's as a first next step for Python programming. I think that's a good thing to consider. And definitely Python gets used within Google a lot. All right, so that concludes. That's the extent of the Python teaching we're going to have today. So thanks very much for your attention. And I'm happy to stay longer if people want to work on their projects. And good luck with Python in the future. All right, thank you. Thank you.